The next thing that we want to look at then is going to be solving absolute value equations. Now, we always have kind of two methods, the algebraic and the graphical method. Now, the first one, the graphical method, this one's very straightforward. You're just going to graph the two sides of your equation, so to the left and to the right of the equal sign, and then just find your intersection points. Now, a lot of these will have two intersection points, but it's also possible to have no solution, so no intersection points, or just one intersection point as well. But your graphing calculator then can easily find those just using that intersect function. And we'll look at those ones then as well. The other one too is not too bad for these ones as well. They're a little bit longer, but again, fairly doable. These are the algebraic solutions. And so what we're going to do is we're going to be solving each of the piecewise functions. So if you remember, every absolute value sign can be broken up into piecewise functions, one with a positive 1 multiplied through and one with a negative 1 multiplied through. And what we're going to look for these ones here is we're just going to take both of those cases, we'll solve for each. That'll give us then two potential solutions, and then we'll check for those ones back into the original to see if they are real solutions or if they're extraneous. Now we can also use the domains of the piecewise functions to check for extraneous solutions, though this is typically going to be a longer way of doing this. The fastest way is just going to be actually graphing them and just seeing where those intersection points are, or even just a test point then to verify is usually pretty quick. When you are if you are using this domains window, then the solution to the piecewise function must be in the domain of that piecewise function. So we're going to be solving for two different values, and each of those piecewise functions is defined over a particular section of the domain, and so the solution that comes out of it also has to match up to that same domain. But again, I would recommend just using test points. It's going to be faster. So this one here, we're going to multiply through the absolute value sign with a positive sign, and so that just gives us then x plus 2 equals 4. And the other one will multiply negative through there. So I get negative x minus 2 equals 4. And that's just breaking it up into the piecewise functions for this side here. So a positive multiplied through the x plus 2 and a negative multiplied through the x plus 2. And at that point then we just need to solve. And so I move the 2 over by subtracting, and so I get x equals 2 as one potential solution. Move the x over to the other side to make it positive, and then I get negative 2 minus 4, and so I get negative 6. And so 2 and negative 6, those are potential solutions. Now don't forget, you can get extraneous solutions with these, so you just want to verify. You don't need to necessarily write out your steps for these, but again, just put it back into that original equation. And so we see for this one here, if I put in a 2 plus 2, the absolute value of that is equal to 4. So 4 does in fact equal 4, and so this one is a solution. On the other side, I get negative 6 plus 2, and the absolute value sign should equal 4. Now negative 6 plus 2 is negative 4. The absolute value of negative 4 is positive 4. And so this one also checks out. So this one has two solutions, one at x equals 2 and one at x equals negative 6. Now we can verify this fairly easily on our graphing calculator. So what I've graphed here is the left side of the equation, the absolute value of x plus 2, and then the right side of the equation, just 4. Now the absolute value piece is then this one in blue, and then that horizontal line then is the x equals 4. And what we see is I have two solutions. And if you can verify that you have two solutions, then both of those are going to be correct. To solve on the calculator, you would just of course go second function trace, and then number 5 there's what you're looking for, the intersection point. Now it's going to solve for the nearest one, so you'll have to do this twice to solve for both of those. But just hit enter, enter, and enter, so 3 times, and we get then x equals 2. Which is this solution over here. And then you can check the other one as well, and you'll see that that one shows up at negative 6. So I'll follow the same procedure for these ones here. I have an absolute value on this side here, so I'll multiply through that absolute value sign by a positive 1 and a negative 1. So when I multiply through by the positive 1, then this negative 2 stays the same, so I get negative 2 times x and negative 2 times 1. So I'll get negative 2x minus 2, and that equals then just x minus 3. Now for the other one, I'll multiply through by negative 1, and so I get a negative 1 times negative 2, so I get a positive 2 that's multiplying through the bracket. And so for my second one, I'll get positive 2x plus 2 equals x minus 3. Now I just need to solve each of those two equations, and they're just simple linear equations, and that'll give me my potential solutions, and I can put those back into the original equations then just to verify. So if I move this 2x over here, that'll give me x plus 2x, so that'll give me 3x. And when I move the 1 over here, I get positive 3 minus 2, and so I get a 1 here. And so this one here, when I divide that out, I get x equals 1/3, and that's a potential solution. For this one here, I'll move this x over here, so I get 2x minus x will just be equal to x. And then if I move this 2 over to here, I'll get negative 2 minus 3, which is going to give me negative 5. And so negative 5 is another potential solution. So I just need to check that back into my original equation. And so I get 2. I'll put then the 1/3 plus 1 in the absolute value sign. And then on the other side, then the 1/3 minus 3. And when you do solve these, then you'll get negative 8/3 on both sides. And so we see that these are in fact equal. And because they're equal, then this is then one of my solutions. Do the same thing with the other side. I get the absolute value sign then of negative 5 plus 1. And then on the other side, just negative 5 minus 3. And when we solve these ones here, we'll get negative 8 now on both sides. And so again, this is also a solution. And so we get 2 solutions then for this particular question. If we go to the graph, we'll see we have negative 2 times the absolute value of x plus 1 on the one side of my equation. And then the right side there, the x minus 3, is going to be in red. So that's my linear equation, and I have the one in blue. And we can see right away we have 2 intersection points. It's kind of near the end of the graph here, but we can clearly see it's going to cross twice. And so even if you had solved both of these and then just check the graph, you can see that they're both real solutions. And again, you can go back through that intersection point to figure out then, or just to verify your solutions of 1/3 and negative 5. For the next one here, again, we see the absolute value sign on one side of the equation. So we'll multiply a positive sign through there and a negative sign through there. So with the positive sign, then of course that one doesn't change. So 2 minus the 3x, and that equals then the x minus 3. And then if we multiply a negative sign through there, we'll get negative 2 now plus 3x, and that equals then x minus 3. So then I can move things over. I'll move the 3x to the other side. So I'll get x plus 3x, so that'll give me 4x on this side. And I'll move then the 3 to the other side. That'll give me 3 plus 2, so 5. And so we see that x then, one potential solution would be 5 over 4. On the other side of this then, I can move this x over. That'll give me 2x on this side, so 3x minus x. And then if I move the 2 over, I get negative 3 plus 2, or negative 1. And so I get x equals then negative half, or 1/2 on the other side. Now I'm going to check both of those as potential solutions. So we go back to our original equation. So I take the absolute value of 2 minus 3 times 5 over 4, close the absolute value sign, and then I get 5 over 4 minus 3. Now if I solve each of these ones here, I'm going to get 7/4 on this side. It'll be positive 7/4, but on this side I'm going to get negative 7/4. So the value is the same, but the signs are different, and so this is not a solution because I don't get the same value on either side. I can do the same thing with this one here. I get my absolute value sign of 2 minus 3 times the negative 1/2, close the absolute value sign, and I get negative 1/2 minus 3 on the other side. So when I put those ones in, I get 7/2 over here, but I get negative 7/2 on the other side. And so again, we see that this is also not a solution. And so this one just has no solutions. Now we can see that fairly easily on the graph as well. So if we bring this one in, I have the 2 minus 3x on the one side and the x minus 3 on the other. And what we'll see here then is that these two graphs don't cross. So here's the absolute value of 2 minus 3x. The red line is the linear x minus 3. There's no intersection points between those. And so we see that there are no solutions then to this particular problem. So we'll do the same thing for this one here. I'll take that 1/2 out front. I'm going to just multiply through the absolute value sign by a positive 1. And that'll give me then 2x minus 5 inside the bracket. And the other side will of course just be 8 minus 2x. Now for the other one, I'll take the 1/2 out front. And I'm going to multiply through by a negative sign through there. So I get the negative 2x. Now this becomes plus 5. And then still the 8 minus 2x to the other side. Now I could multiply this 1/2 through the bracket, but that will give me 5/2, which isn't the easiest thing to work with always. So I could also take this 2, and I could multiply both sides of the equation by 2. Now when you do that, remember you have to multiply the whole thing by 2. If I do that, I get 2x minus 5. I get 2 times 8, which is 16, and then 2 times negative 2, which is negative 4x. And that might be just a little bit easier to solve. So this negative 4x plus 2x will give me 6x on this side, and then the negative 5 moved over will give me 16 plus 5, or 21. And so we see that x then just equals 21 over 6, or if we reduce that, we can divide both by 3. I get 7/2 then is my value. For this one here, I'll do the same thing. I'll multiply the 2 to the other side, again, just to avoid fractions. So negative 2x plus 5. And this will give me then the same as before, plus 16, and then minus 4x. And again, don't forget to multiply through both terms. So if I add this 4x to the other side, I get 4x minus 2, which is then just 2x. And I can subtract this 5. I get 16 minus 5, which is 11. And so my other potential solution will be 11 over 2. Then I just need to check each of those solutions and see which is correct. So for this one, I'll get the 1/2. And remember, we are going back to the original equation for these ones here. Times the absolute value of 2 times 7 over 2, and then minus 5, close the absolute value sign. And that should be equal then to 8 minus 2 times 7 over 2. Now 2 times 7 over 2 is just 7, so I get 7 minus 5, which is 2. The absolute value I get of 2 is positive 2, times 1/2 just gives me 1. This one here, again, 7 over 2 times 2 is just 7, so I get 8 minus 7, which is 1. And so we see then that 7/2 is a solution because 1, of course, equals 1. So we can, again, go check the 11 over 2 as well. Always come back to the original equation. So we get 1/2, the absolute value of 2 times the 11 over 2. And then minus 5, close the absolute value sign. And then I get 8 minus 2 times 11 over 2. So inside the brackets here, we see we have 11 minus 5, which is going to give us 6, divided by 2 is going to give us positive 3. On the other side, we get 8 minus 11, which is negative 3. So we see that those two aren't the same. And so then this is going to be an extraneous solution or not a solution to our problem. We can see that fairly easy from the graph as well. When we graph these two out, so my blue one is the piece with the absolute value function, and then the 8 minus 2x is just this line, we see that there is only one crossing point between those, or one intersection point. And if you solve for the intersection point, that'll show up at that 7/2. And so we can see that the 7 over 2 is our solution, and then this 11 over 2 is a non-solution or an extraneous solution. And some questions will ask you to find that extraneous solution, so just make sure that you know what that's referring to then as well.